All right, let's define what we're going to use a great deal, and that's called a critical number. So a critical number is the number c, so it's an x value has to be in the domain of the function. That's something that's going to become critical, that either the derivative equals 0 or the derivative doesn't exist. So what that looks like would be the top of a parabola. That would be the derivative equals 0, or the derivative doesn't exist could be like a cusp right there. All right, if it is a local min or max, then it is a critical number. If it's a critical number, it could be a local min or max. So make sure you've got the difference between those two. All right, let's go find critical numbers. So let's take the derivative. So 3x squared plus 2. There's going to be no places where the derivative doesn't exist, because that would be where the denominator equals 0 or something. That's not happening. So 3x squared equaling negative 2. Right there, I can just stop, because I know that 3x squared cannot equal negative 2. So there's no critical numbers. So this must be a graph that is, by looking at the derivative, it's always positive, so it must be always increasing. All right, let's try this one. K prime of x is 1 minus 1 over x. All right, to looking at the derivative, I can see that the derivative does not exist at x equals 0, right? Cannot use x equals 0 inside here, but stop and look at the function. Can I use x equals 0 inside the function x minus ln of x? I cannot, because I cannot put x equals 0 inside. So this is not a critical number. So not a critical number of the function. All right, so where is the derivative equal to 0? So if I set 1 minus 1 over x equal to 0, I get 1 equal 1 over x, so I get x equal 1. That is in the domain of the function, so this is the only critical number. All right, so this is, you know the graph of this. It looks like this. And there's no way to take the derivative with a power rule of absolute value of x minus 2, but I do know critical numbers happen when derivatives equal 0 or doesn't exist. So I know the derivative doesn't exist at x equal 2 because it's a corner, because you have to know everything all the time, right? It is in the domain, so x equal 2 is the critical number of this function. All right, so dealing with different letters here, derivative of theta is 1. The derivative of tangent is secant squared of theta. So setting this equal to 0, I get secant squared of theta is 1. Taking the square root, I get secant of theta is plus or minus 1. So I like to deal in terms of sines and cosines. So cross multiplying, I get plus or minus 1 is cosine. So what does that mean? Cosine of theta is 1, or cosine of theta is negative 1. So this happens at x equal, theta equals 0 and 2 pi, and here theta is pi. So those are all in the domain of the function, and they are included in the domain here. And so let's stop and look at when does this derivative, 1 minus, and I'm going to rewrite secant as cosine, 1 over cosine squared, when does this not exist? So this would be when cosine is 0, correct? But that would be when cosine is 0 in here. So this would give us values of theta that are not in the domain. So we don't have any critical numbers that are from where the derivative doesn't exist. So these here are our critical numbers. All right, just a couple more here. So take the derivative, cosine of x, and then this turns into plus sine of x. Set it equal to 0, so cosine of x is negative sine of x. So when does that happen on our unit circle? When are cosine and sine the same number except differing by a negative? So I see, this is asking me for all reals, but I see it's going to be these two pi over 4 terms. And because they're separated by a pi, I'm going to say x is equal to, this is 3 pi over 4 plus all k pi multiples. because this is just a value of pi to get from one to another. So that's it. Last one. So take the derivative. I get 2 cosine of x times negative sine of x. And then, because that's chain rule happening, and then minus 2 cosine of x. Setting it equal to 0. So be really careful. Factor out the 2 cosine of x. How about even we factor out a negative 2 cosine of x? So inside here, I'm left with a sine of x plus a 1 equaling 0. So now I have cosine of x equaling 0 and sine of x equaling negative 1. So if you had divided through by cosine, you would have lost these answers. So cosine is 0. Again, we're back to 0 to 2 pi. So this will equal, or this will happen at pi over 2 and 3 pi over 2, and this will equal, or will happen at 3 pi over 2. So these two values alone.